So, the first part is we're talking about angular displacement. If you'll recall, this is exactly where we started on day 2 in this class. Okay? This was day 2. I believe the first day. Wasn't that the pre-assessment, or was it the second day of the pre-assessment?
No, the first day.
First day pre-assessment. So that means the second day, we started going over displacement and distance, right? Which is, you weren't here. Like, you know, she just nodded her head and she wasn't here. She has no idea. But this was the second day. This is not much different, except for your displacement is around a circle. Okay? That's the only difference. Okay? So there's 3 ways to measure displacement. Degrees, which you guys should be pretty familiar with. Let me find a beautiful marker that works well. I'm sure I got plenty. Oh, how's that? I just don't want my dad. Don't worry. Wait for it, right? How's that? Alright. So you can measure displacement in degrees. Degrees is 90 degrees, 180, so on and so forth. Something you've already done. So over here, 0 degrees, 90, 180, and 270. And then back to 360. That's nothing that they're doing for you. If you don't know that, then you missed several questions on other chapters. Okay? So that's the circle. If you draw a circle, it's 360 degrees. I turn all the way around, it's 360 degrees. Okay? Revolutions. Now, if something goes around a full circle, we call that how many revolutions? 1. So you already know what a revolution is. From start to finish, no matter where you are, that is 1 revolution. So all the way around is 1 revolution. Okay, and I go around 16 times, that's 16 revolutions. Okay? So far this chapter isn't too hard. Radians is where it's going to get a little bit tricky. How many people have heard of radians? A few less than last class, but quite a few. So radians is 2 pi radians is 360 degrees. Okay, 1 revolution. You probably use a pre-count is what I heard. Let me show you how it looks, and then hopefully you guys can calculate between the 2. So if 1 full revolution is 2 pi.
I'm sorry for this interruption. Ms. Crawford, this is Ms. Melton. Please report to the main office to Ms. Atwood's side. Ms. Crawford, you're in the building. Please report to Ms. Atwood's side. Thank you.
If 1 full circle is 2 pi radians, at 90 degrees, that's half pi radians. 180 would be pi radians, and then 270 would be 3 halves pi radians. Okay? That's essentially just saying, hey, you went 90 degrees around that circle. So if this ball goes from here to the bottom, it went 90 degrees, or it went half pi radians. That's this angular displacement. Okay? It's magic. Hey. Yeah, I know magic, right? But this is 90 degrees, right? So this would be half pi radians. From here to here is pi radians, and that's how we can tell the angular displacement from one location to the other. Okay? Simple enough? We're going to work with converting from one to the other here in a second, after we learn what arc length is. Has anybody heard of arc length?
Yes.
Dang, you guys are awesome. Some of you are. Some of you know. Others, you learned something new today. You learned more than one thing, hopefully. So, arc length is the change in distance from a point. So yeah, I mean, it's pretty much the linear expression of this angular displacement. Let me say it again, it's probably the linear expression, and I say linear because it ends up in meters per second, of this angular length, or angular displacement. So there's 2 different ways to calculate. There's S equals 2 pi Rn, where n is the number of revolutions, or there's S equals R theta. I like both of those, where theta would have to be in radians. Okay, theta is in radians. So those are your 2 equations for that. If I have this whatever it is, circle, and suppose I go that far, okay? My S is just however far I went. So it'd be S equals R theta. You would have to know two things. You'd have to know the radius that circle is. Now that's not a very good circle, I'm sorry. You'd also have to know how many degrees or radians or revolutions that is. Right? So we're about to do a couple of examples of that here in a second. Okay? So the next slide. An automobile wheel has a radius of 42 centimeters. If a car drives 10 kilometers, through what angle has the wheel rotated? And we want to know in revolutions, in radians, and in degrees. Okay? Sir? Linear expression of the angular displacement. So, if we read what we know, 42 centimeters, that's the radius. What's wrong with that? What does it need to be in?
It needs to be in
Meters. Everything's always in meters. Okay? So that'd be in meters. So it's 0.42 meters. If you don't know how to go centimeters to meters yet, you divide by 100. Divide by 100. And then it says if the car drives 10 kilometers, through what angle has the wheel rotated? Okay? This is probably going to be the hard part to figure out. What the heck is 10,000?
10,000 pounds?
It's 10,000 kilometers. So that's the distance that you drive. So we think about it, and remember the S we just drew? The S looked like a tire, right? Okay? Matter of fact, if it's a tire, it's going to touch the ground in each and every location on that S or on that wheel. Okay? So the arc length is actually the tire. Okay? Or the distance that is traveled. Because you have to go around. You do that for 10 kilometers, or 10 kilometers in this case, all the way around. So your S value is 10 kilometers. And what's wrong with that? It has to be meters, yes. So that equals 10,000 meters. Okay. Now you have two formulas that you can use. You can use the first one, which is S equals 2 pi R times N. And the second one is S equals R theta. Which one do you think we're going to use for this first question?
2 pi R.
The first one, right? Because we need to know the number of revolutions. So you can plug it in. To solve for the number of revolutions, which is what we want, we're solving for N, we can use N equals, you reorganize it, you divide by 2 pi R, S over 2 pi R, which is 10,000 meters divided by 2 pi times 0.42. Second, they'll ask us if I cared if it was in with pi as a unit or not. You can leave pi there if you want. It doesn't matter. You can factor it out. You can multiply, or in this case, divide by 3.14, whatever you want. Okay. In most homework problems, it takes out pi. Okay, so you divide by 3.14, or you use the pi button on the calculator. So what is the value of n? And I have to do quick math in my head. 3,789 revolutions.
You said revolutions?
Good job. Good. Okay. Yes. No worries. Yep, 6. I apologize. You get 3,789 revolutions. That's how many times that tire went around. Okay? Part B, you can either change revolutions into radians, or you can just use our new equation, S equals R theta, to find our angle in radians. So I would prefer to use S equals R theta. That's a good find. How about that? That's
Nice marker.
Nice marker.
S equals R theta. If you do this, your theta in radians equals S divided by R, which is 10,000 meters divided by 0.42, which gives you, I'm cheating, 23,800 radians. What you notice is that meters divided by meters will cancel out. So he got 809, you're correct. They rounded the answer. Meters divided by meters should give you no units, right? Well, a number without units has no meaning, right? For example, you are 17, or 18. You're inferring my units of years. Okay? So you have to have units even though meters canceled out. They chose to put radians as the unit because they have to tell you what's going on. That number has to have a purpose. Okay? So radians is the unit here. If you ever add or multiply by meters, it's just meters. Okay? It's just arbitrary unit that they placed there to hold the spot. So that's how many radians you have. For the third one, we need to convert it to degrees. So to do this, you can use either one. You can use revolutions or radians. Since we know one revolution is 360 degrees, it's probably just easiest to use that one. You can use this one as well, which would be 2 pi radians equals 360. Since you know from the first slide that right here, 2 pi radians equals 360 degrees, which equals 1 rev. Okay? So 1 rev equals 360. That's what we're going to use in this problem. So 23,800 radians over 1. We need to change that into, oh, we were going to do revolutions, weren't we?
Yeah.
That's fine. Thank you. 3,789 revolutions. You'll get the same answer either way. To change this into degrees, 1 revolution equals 360 degrees. So all you do is multiply those. 360 times 3789. Once again, you get 1.36 times 10 to the 6th degrees. Okay? Let me bring out something like that different. Right? Pretty good. Pretty good. Alright. So all of that is angular displacement. You can do it in 3 different ways. The most common way to do it is in radians. But you will have to distinguish between the 3. So this slide will tell you how to do it. Same answers. Yeah. Still, I took the answer.